Hello guys, welcome back to our channel. So today we are going to start a brand new series, Recursion, where we studied about recursion using JavaScript. And in this series, we will implement the mathematics like algebra to prove or understand the recursion in JavaScript very easily. It will be quite more easy to understand in JS using mathematics like algebra. So before starting the video, I would like to tell you something like I'm going to start the video in Hindi as well as English. So I will upload English as well as Hindi video alternatively. Means if I am uploading like Monday in Hindi, then Tuesday will be in English, the same video. So if you are comfortable in Hindi, then you can go for Hindi. Otherwise, if you are comfortable in English, so you can approach the English video. So guys, let's start. So today's topic is recursion. So what recursion is? In very simple language, recursion is a function called himself. So if we will write the like definition, so we will write here like those function who called himself that is recursion. Here guys, it may be possible that I have some sort of English spelling mistake, so please correct from your side. Actually, it is quite unfortunate to write so fast, so like we can't focus on spelling. We mainly focused on the term and how we can make you understand and make you feel comfortable. So that is the recursion here. And some sort of algebraic term, like we start from algebraic term, like there is a function in algebra like f of x, where x equals to f of x equals to x square, right? So how will we write this algebraic function in JavaScript? So we will write here like function fun. This is f of, so f of x, fun of x, and a block open. Here we will return x square, so x multiplied by x, right? And block close. So how will we call f of x in for any number? So we will call f of x for, like we are calling for 5. So what will be here? So f of 5 will be 5 square of 5, then it will be like 25, right? So how will we do the same in JS? So we'll here we will call the function. Which function? Fun. So here we will call fun of 5, right? So what happened in this step, in this code? So here we are passing 5. So here we are calling fun and passing 5. So here the argument will be 5, and this 5 will replace x here as 5 and 5. So what will be the result of this function? This function will produce the square of 5. It will be 25, right? So here 25 here as well as here too. So what function is, right? Exactly. So function is like this is a tool to express the algebraic expression in programming language, right? So function. So we are like I'm telling you with the perspective of mathematics. So what will be the function in programming language? So this will be like the tool to express the algebraic expression in programming language. That is called function, right? So now in algebra we probably studied in 11th and 12th, that is a PMI. PMI means the principle of mathematical induction. So mostly we studied it very long time ago in 11th and 12th, right? So what is the formula of PMI? That was sigma of I equals to 1 to n for I equals to n of n plus 1 by 2. It means like from 1 to n, the sum of 1 to n will be n of n plus 1 by 2, right? This is the formula. So here what we do, like here how we will prove that formula actually. So we do like we assume. So here what we will do to prove this formula, what will we do? We assume that n equals to k. We assume that this formula is satisfied by for n equals to k. If we assume that for n, if we put the value of n as a k, then this formula will be satisfied. We are assuming here, right? So assume n equals to k, the formula will be satisfied for n equals to k. So assuming n equals to k, we will prove for what? We prove for n equals to k plus 1 and prove for n equals to 1. So we will try to prove for n equals to k plus 1 and n equals to 1. So what we wrote here, we wrote that let's assume the formula is true for n equals to k, which I told you earlier, right? And so prove that formula hold true for n equals to k plus 1. Okay, we have to prove these two, like n equals to for n equals to k, and we also prove for n equals to 1. So prove that the formula hold true for n equals to 1, right? So what happened here? We assume that the formula is satisfied by n equals to k, and to assuming n equals to k, we will prove for n equals to k plus 1 and n equals to 1. To using n equals to 1, we will prove for n equals to 2, for a 3, and so on for a k and k plus 1, which is the same here, the same term. So eventually what happened? Eventually here this formula basically, this formula holds for all the natural numbers, which is here we can see that 1 to k plus 1. So it holds for all the natural numbers, right? So we will try to prove that actually this was the theoretical understanding. So now we will prove that particular formula. So what will we do? We will to prove sigma of I equals to 1 to n for I equals to n of n plus 1 by 2, right? We have to prove that. So earlier, as I told you, that we assume for n equals to k. So here we also wrote that assume that the truth of formula for n equals to k. Okay, so implies that we will put the value of n, which is k, instead of n. So what will be wrote here? Sigma of I equals to 1 to n, and what was the value of n? That is a k. So we will put here k. So sigma of I equals to 1 to k for I will be k plus 1 by 2, right? Here is the new formula which is formed. Okay, so we assume that this formula is satisfying our base formula. Okay, so now what will we do? We will prove for n equals to k plus 1. So to prove for n equals to k plus 1. Sorry guys, what will be right here? We will write I equals to 1. Here the new value of n will be k plus 1, right, for I, and then the value of n will be k plus 1 of n. N means k plus 1 plus 1 by 2. We generalize this, so it will be ultimately k plus 1 and 1 plus 1 2. So it will be k plus 2 by 2, right? So we will pick the left one. So here the left hand side LHS. So we will try to solve the LHS. So what will we do here? So sigma I equals to 1 to k plus 1. for I, what will be the what will be the sigma I equals to 1 to k plus 1 will like from 1 plus 2 plus 3 plus so and so on plus k plus 1. This will be the whole term, right? So as we assume here, we can see that here the formula is already proved for what, for k, right? From 1 to k. So we will put here from 1 to k the value of 1 to k. So what will be here, the value of this term? So it will be like sigma of I equals to 1 to k for I, right? This will be the value of that these terms. Okay, so we will put the value of sigma I equals to 1 to k. So what will be the value? This value will be here like k of k plus 1 by 2. Here we put these values, the value of this term. So and what rest here, the rest term is k plus 1, right? So we solve with this. So what will we do? We do like k of k plus 1 by 2 plus k plus 1. So we will take the LCM. So what will be the LCM? 2, then k of k plus 1, and then plus 2 will be multiplied by k and 1 as well. So what will be here? 2k plus 2, right? So we will take the common 2 here, and it will be then the rest term will be k plus 1. So from k plus 1 we will take the term k plus 1 here as common here, from here to here. So the term will be k plus 1, we take the common, and then next term will be k plus 2, right, by 2. So this is our LHS, right? And as we, if we will see that our LHS was that one, and what was the RHS? RHS was this term. So now this term is same as the LHS. So LHS equals to RHS, right? So by using formula from n equals to k stage. Actually we assume that this was staged, like this was proved. So we are we take the help of n equals to k, and we prove formula for n equals to k plus 1 stage. Okay, so now we are going to prove for n equals to 1. So for n equals to 1, sigma of I equals to 1 to n for I will be n of n plus 1 by 2, right? So here we will take the LHS. LHS will be this term. So LHS will be 1. Okay, so we will replace n as a 1. So here it will be I equals to 1 to 1 for 1 will be 1, right? And the RHS will be n of n plus 1 upon 2. So we will replace the value of n to n. So 1 of like 1 into 1 plus 1 by 2. It will be 1 into 2, ultimately 2 by 2. It will crossed and equals to 1. So here LHS equals to RHS. Okay, so here we assume for n equals to k, and then prove for n equals to k plus 1 and n equals to 1. So it means it will satisfy the it will hold for all the natural number. Okay, So that's it for this video. So we will connect this PMI theorem to JavaScript program in our next video. So till then, take care and bye-bye. I will provide the link for source code of this solution in description, so you can go through our link, which will be in description, and get the code, right?